Good morning, Year 8. Thank you for engaging with our online lessons. Today should be drawing them to a conclusion. So there's no need to register on Show My Homework today. I can get names from the online form you'll be filling in at the end. This isn't as strenuous as the test in the previous lessons, so don't worry about that. So last lesson was your quiz that was based on our online learning sessions, and today's we're going to go through the reflection time for that. So I'm going to go through the answers to those questions, and then there's going to be a quick form to fill in at the end where I'm going to ask you to rag rate each of the topics once I've given you a reminder of the working out, because it may just be that you'd forgotten in between those lessons, but actually once I give you a reminder you are comfortable with that work. So there's probably no need for you to watch all of the video here. I should have sent your quiz questions back to you with the marking. So the marking might be slightly different than it was the first time you did the quiz. There's some different variations of answers I've allowed as well. So watch the questions that you got incorrect, see if you understand my working out for them, and then if you can rag rate your topics, that'd be fantastic, and it'll give your teachers a good chance to have a look over what we need to do in September. But it will also give you a list of topics that you may wish to look back over the videos of before we return. So without further ado, I'll move on to those questions, and as I said, please skip forward just to the ones that you were unsure of or the ones you got wrong, rather than watch every video, because it's going to be quite a long video today. So the first question that you had, aside from giving your name, form, etc., was this one. It was estimate the answers to this question by rounding each number to one significant figure. So the first one that threw quite a few people it seems, used 42 as the first number. That isn't rounding to one significant figure. This first number's in the tens, so we just need to round it to 40. And you will have to excuse me some very dodgy mouse handwriting in this video today. So the second number is in the units. It starts off, so we can have that as 8, so we get 40 plus 8, and then that's over 3.987, so that number's in the units, so round to the nearest unit, so that's going to be a 4. So do the sum here. Obviously BIDMAS wise we need to do the numerator before we can actually do any division, so you get 48 as the numerator, and we're dividing that by 4, and therefore we get 12 as our final rounded answer. If you did 42 there, you're not actually following the exam command word of estimate. Your sort of guess is actually going to be slightly more accurate than the answer of 12, but estimate is one of those key exam words, and you have to do that in a very particular way, which is our rounding to this one significant figure. So it must be 12 as the only option for the answers here. So question 7 here, we've got another estimate question. The particular wrinkle on this question is that we're going to be dividing by a decimal at the end here. So let's run through the question though. 3.961 rounded to one significant figure is 4, because the number starts off in the units. 4.215 also rounds to a 4 to one significant figure, and that's going to be squared. And then 0.019, well, the first digit non-zero here is the hundredths, so we need to round this to the nearest hundredth, so we get 0.02. Let's run BIDMAS on our numerator. 4 squared is 16, and add the 4 gets us 20, so we end up with 20 divided by 0.02. Now if you're not comfortable with doing this straight away, then we can use some equivalent fractions here. For times the numerator and denominator by 100 here, or get rid of the decimal part, we'd end up with 2000 divided by 2. If you times numerator and denominator by 100, and obviously that's going to give us an answer then of 1000. So our estimated answer here should be 1000 for this question. Number 8 then, we're after an inequality statement for the length of a piece of wood which is measured as 526 to the nearest centimetre. So remember, if you've got these inequalities, you can go half of the measurement either side. So if you're measuring to the nearest centimetre, you can go half a centimetre either side. So we're definitely looking at the 525.5 and the 526.5 ones. So it's not going to be our first one that goes a centimetre either side. But which one is it? Here we've got the inequality symbols the wrong way round, because we've got the x is smaller than 525.5 and bigger than 526.5, so it's not this one either. The other two were very, very similar. Just watch out, the bottom one had the inclusion of the equal sign. Remember, as far as numerical answers go, if it asks what is the largest value that x can be, we can say that it's 526.5. But in our case, for the inequality symbols to be correct, x should really be slightly smaller than 526.5. So we need this one that's highlighted in green that just had the less than symbol here, not the less than and equal sign. Number 9 then, the length of a picture frame is 36 centimetres and the width is 12 centimetres, both measured to the nearest centimetre. What is the smallest possible area? So let's do the bounds for these numbers. If it's measured to the nearest centimetre, we can go half a centimetre either side. And to minimise an area calculation, we want the smallest length and width. So we're going to have a 35.5 as our smallest length, and we're going to have an 11.5 as our smallest width. And if you plug that on the calculator, 35.5 times 11.5, we end up with 408.25. As I did say, excuse some dodgy mouse handwriting today. We need to give units for the answer. It's an area here, so it needs to be centimetres squared. Centimetres will lose you a mark on this. So 408.25 centimetres squared. Don't go and do 36 times 12 and then try and unround that answer. It's got to be the rounding done first and then get your answer accurately. Number 10, find the lowest common multiple of 36 and 22. Well, one way of doing this is to have a look at your common factors. You might be able to spot one of the common multiples first off by writing the times tables, but if we go through the more complicated method, then we'll see how comfortable people are with that. So find the lowest common multiple of 36 and 22. So we could do the prime factors of 36, which is 2 times 2 times 3 times 3. We do the prime factors of 22, which is going to be 2 times 11. Well, if you pop that in on a Venn diagram with the left hand circle for 36 and the right hand circle for 22, there's only a 2 that's actually shared between them. There's going to be a 2, a 3 and a 3 over here, and there's going to be an 11 over here. Remember, if you want the lowest common multiple of these numbers, then you times everything in the Venn diagram together. So we want 2 times 3 times 3 times 2 times 11, and that's going to give us 396 as our lowest common multiple of these. So remember, a few people I saw had double this number and it looked as if they'd put the extra 2 in, and there's a 2 shared between our common factors, so it only goes once in the middle of our Venn diagram here. Number 11 then, we've got highest common factor of 42 and 70. We do this in a similar way with the Venn diagrams. So let's get our prime factors of 42. You can do the factor tree if you want, but I know that 42 is 7 times 6, and 6 is 3 times 2. So 7 times 3 times 2. And then 70, again, you can do a factor tree if you want, but I know it's 7 times 10, and so that's going to be 7 times 5 times 2. Let's pop those in a Venn diagram. Again, left hand circle is for 42, right hand circle is for 70. There's a 7 in both. There's a 2 in both. And there's a 3 just for 42 and a 5 just for 70. And then our highest common factor is the intersection in that. So there's a 7 and a 2 in the intersection. So 7 times 2 is 14. So 14 is the highest common factor here. Area one here, it's a compound area, so split it into 2 shapes that we should be aware of. So 2 rectangles here. So 9 times 8 is going to be the area of this rectangle. So 72, 5 times 7, 35, add those together, we get 107. I did say don't include units in the answer because the way the answer was formatted there, it would have been very difficult for you to get the squared in. So it should be 107 centimetres squared, but 107 was the number I was after for being typed in as your answer. Number 13, we've got the area of a trapezium. So remember the formula for the area of a trapezium is a half brackets A plus B H, where A and B are the parallel sides of your trapezium. So parallel sides here, we've got the arrows on them, so we know that that's 6 and 10. So it's a half brackets 6 plus 10, and then times by the height, and the height of this is 5. And remember, we've got these like hidden multiplication signs when we write in algebra. So then run it as a BIDMAS question. So 6 plus 10 is 16. Half of that is 8, and times it by 5 gets us 40. Once again, strictly speaking, it should be 40 centimetres squared, but we did say don't include the units just because of the problems with formatting on the online form that you had to fill in. So question 14, we have the area of this shape, so the area of a circle in centimetres squared, and give your answer rounded to 1 decimal place. So here we've got a radius of 4 centimetres, so remember the area of a circle is pi times the radius squared, so we want pi times 4 squared. You should be able to do this accurately on your calculator and then round afterwards, so we want pi times 16, and then that's going to give an answer of 50.26 as 26548, but we need, just for our rounding purposes, we need 1 decimal place. So if you cut that off at the 1 decimal place, there's a 6 after our cut-off points we need to round up, so it should be 50.3. So once again, we didn't want units in the answer, we're at 50.3 centimetres squared. So question number 15, we have the area of a sector. If you did this question within the first few minutes of the quiz going up, it actually said centimetres squared here. I think one person did that, which was fantastic to see, but they didn't round the answer correctly at the end, so unfortunately you didn't get the mark. But after that I did change it to metres squared, so don't worry, I would have marked it correctly, and I did check all the answers for that. So here we want the area of this shape, and the answer rounded to 1 decimal place. So we need to treat it as a full circle, and the area would be pi times the radius squared. Well, what's the radius? It's 7, so we want pi times 7 squared if it was a full circle. However, it isn't, so we need to know what fraction of a circle it is. Well, the simplest way for doing it on the calculator is to write it as 36 360ths, because that's the proportion of a circle that we've got, with a full circle being 360 degrees. But the more astute of us will notice that 36 360ths is the same as a tenth. So we can just do pi times radius squared and divide it by 10, because we have a tenth of a circle here, 36 360ths. Pop that in on the calculator and you're going to get 15.3938. Again, excuse this mouse handwriting here, that's terrible there. And then we can round that to 1 decimal place, so we should end up with our 15.4, which after our cut-off point is a 9, so we need to round up there. Again, we're not giving answers just because the complexity of putting the squared symbol in there. I think 1 or 2 people actually did manage to copy and paste it from somewhere and get it in, which was fantastic. I have adjusted answers to make sure it automatically marked that as correct. So 15.4 is the answer we're after. Number 16, a sports car travels 30 miles in 30 minutes around the track. Calculate its speed in miles per hour. We should know that speed is distance divided by time. So the distance travelled is 60. The time taken is 30 minutes. But remember, our speed needs to be in hours, so it's actually 60 divided by 0.5 that we're after here, that caught a few people out. So a few people had 60 divided by 30, which gives us 2 miles per hour. Doesn't really get you 60 miles in 30 minutes. So look at the justification of your answer there. 60 divided by 0.5 gives us that 120. And then mph, or miles per hour, or m/h, depending on how you wanted to put it. There's a variety of answers that would have been marked correctly on that one. So 120 miles per hour for distance divided by time, but the catch there was that time needed to be in hours. Number 17, we have a density question. So remember, density is mass divided by volume. What do we need to work out? We need to work out the volume. So we're going to want then mass divided by density. So the mass is 50 grams. The density is 0.4. So we want 50 divided by 0.4, and that's going to give us 125. And that should be centimetres cubed. So I did say don't include units because we wouldn't have been able to get the cube sign very easily into our answer. So 125 is the answer that we're after. Number 18, we've got a pressure question. So in the triangle that we're after here for our compound units is pressure equals force divided by area. What do we need to work out? We need to work out the force. So if you cross out force, that gives us pressure times area. So 16 times 10, or 10 times 16 to be strictly true in the formula that I wrote before. That obviously gives us 160. And then units for our force, we've got newtons, so 160 newtons there. Number 19, evaluate 2 to the power of 5. Well, it's 2 times 2 times 2 times 2 times 2, until we've got 5 of them. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, and times another 2 is 32. So 32 is the value of that answer. That's the evaluate, means find that final number answer to it. Number 20, which answer is equivalent to the following expression? Well, we can see the correct answer here, but 5 to the power of minus 3 means that we cube 5, that's the 3 part of it, so 5 cubed gives us 125. And the negative part gives us a reciprocal, not a negative answer. So it's 1 over 25, the reciprocal of 125 there. Number 21. Simplify the following and write your answer as a fraction in its simplest form. So we've got 5/3 to the power of -2. If we deal with the 2 part first, then that means that we square our numbers in our fraction. So that's going to give us 25 over 9. We then deal with the negative part of our power here. Negative part there means the reciprocal. So we flip our fraction, which gives us 9 over 25. 9 and 25, don't share any common factors, so we're not going to be able to simplify, so we're done for our answer here. Number 22, which answer is equivalent to the following expression, 4 to the power of 3 over 2? Again, we can see our correct answer, but how do we get there? So we want 4 to the power of 3 over 2. The denominator, remember, means a root, so we're going to take the second, i.e. the square root of 4, which is 2. And then we then cube that answer. So 2 times 2 times 2 gets us our 8. So it's the square root and then cubed. You could do it in the other order, but mental calculation, it's going to be easier to do that square root first. So we should have 8 as our final answer here. Number 23, expand the brackets and simplify. So a couple of people that didn't simplify the answers at the end. So if we do a FOIL method, I'm going to talk through FOIL but draw it as a smiley face. So we need first terms times together, so that's x times x to give us x squared. O is our outside terms, so that's x times minus 4, so minus 4x. I is inside, so 3 times x, so plus 3x. And L is last, so a 3 times a minus 4, so that's minus 12. Collect the like terms, there's only one single x squared term. Collect the x's, minus 4x, but plus 3x leaves us with a minus 1x, so just a minus x. And we don't write those ones in algebra. And there's only one normal number term, so minus 12. And we're done. Exactly the same idea with question 24. So I'm going to talk through FOIL and draw the lines in for the smiley face method. So first terms, 2x times 3x is going to give us 6x squared. O for outside, so 2x times minus 5, so that's minus 10x. I for inside, so that's 4 times 3x, so that's a plus 12x. And then L for last, we have a 4 times minus 5, so that's going to be a minus 20. And a real common mistake people are making on this one is they're doing minus 4, add minus 5, so they got minus 1 as the last term. Remember, it's multiplication throughout this, and so you collect like terms. So like terms wise, we've only got one x squared term, so it's 6x squared. Minus 10x, but plus 12x's is going to give us a plus 2x overall, and then a minus 20 at the end for our final term. And done. Factorising a linear expression here, which means put the brackets back into it. So we need to work out what can we actually divide these terms by. So there's no common letter in them, so we're only looking for a number here. Both of these numbers are divisible by 2. So we put a 2 outside the brackets and then actually divide our terms by 2 to go inside. So 6x divided by 2 is 3x. And a positive 8 divided by 2 is a positive 4. So 2 brackets 3x plus 4 for our linear factorisation. 26, we've got a factorisation of a quadratic here. So this one has just a single x squared in it. So we're looking for quite a nice factorisation here. This was the more simple one. And we're looking for an x in both sets of brackets. And then we're looking for 2 different numbers that have a sum of positive 7 and a product of 12. So 2 numbers that times to make 12 and add to make 7. So we're looking at 4 and 3 here. So we can have an x plus 4 and an x plus 3. Or the other way around, x plus 3, x plus 4 is another answer for that one. That's definitely a plus sign in here. Again, apologies for the mouse handwriting. And then we're done. So number 27, we're going to be factorising a quadratic again. The only difference here is it gets slightly more complicated with some negatives coming in. So x squared plus 2x minus 8. We've still only got a single x squared here, which means it's our easier version of the factorisation. So we can go straight to our brackets with an x and an x. Then again, we're after 2 numbers that have a sum of 2, but have a product here of negative 8. So numbers need to times to make a negative number, add to make a positive number. That means we've got a positive and a negative number there. Otherwise we couldn't get a negative product at the end. And then we know that if we've got a positive 2x overall, we know that the larger of our numbers is the positive one. So factors of 8, then we can go looking at numbers we're looking for a 4 and 2. And we need to know that it's a positive 4 and a negative 2. So the numbers add together to make 2, but times together to make the minus 8. And again, we are done. So number 28, yet again, factorising a quadratic. This one, however, has the 4x squared, so it's our real top end work for factorising quadratics where they have a coefficient number in front of x squared. The difference with these is that you can no longer just look for numbers that add to make 16 and times to make 15. And we can add to make 16, that's fine, but it needs to multiply to make the product of our first and last terms. So the product of 4 and 15, so it needs to times to make 60. Now this doesn't mean we can just jump straight to our brackets either. This was a little bit more complicated method. So we're looking for 2 numbers that add to make 16 and times to make 60, which are going to be 10 and 6. But all that does is it breaks down our 16x. So we now know that when someone multiplied out these brackets, they had 4x squared plus 10x plus 6x plus 15. So we now need to actually work out, well, what brackets did we have to get that? Now I know that some people will be taught that you can just draw a line between and factorise each side, but I like to draw the little grid just so we can happily find all of our factors. So we're going to have a multiplication grid here, then we're going to look for our common factors of these terms. So we're going to put the 4x squared in the top left, we're going to put the 15 in the bottom right, and then it doesn't matter where the 10x and the 6x goes, so let's put them as 10x and 6x, and then look for our common factors. So vertically in the first column, the numbers are divisible by 2, and the terms both have an x in there, so 2x. Second column downwards, the numbers are divisible by 5. First row going across, the numbers are divisible by 2 and x. And then bottom row, the numbers are divisible by 3. Let's just check that works. 2x times 2x is 4x squared, yes. 5 times 2x is 10x, yes. 2x times 3 is 6x, yes. And 5 times 3 is 15, yes, this works. So our column and row headers are going to be our brackets. So we have a 2x plus 5 as one bracket, and a 2x plus 3 as the other bracket, or of course the other way around, 2x plus 3, 2x plus 5 will get us there as well. So a more long-winded process, but it's a real top end of factorising quadratics. So at number 29, we've got to make x the subject of a formula, so changing the subject of a formula. So we have 4x plus c equals w. So x has been times by 4, then we've added a c to get w. So let's reverse that in order. The last thing we did on the left hand side was the add c. So we're going to take c from both sides. So that gives us 4x equals w minus c. And then x is being multiplied by 4 on the left hand side still, so we need to get rid of that. So divide by 4 on both sides. And that gives us x equals w minus c all over 4. There are a couple of the variations that people could have had. You could have a quarter w minus a quarter c, obviously equivalent to that. I have checked through, and if you've got something slightly different, you may well have find it marked correct if it's equivalent to this. So number 30, we've got another change the subject of a formula, but this is a more advanced version because the subject that we're after, m, actually appears more than once in the formula, so we need to isolate that. So the first problem we've got is that the m is on the bottom of a fraction as well as on the top of a fraction. So let's get rid of the fraction first. So if we times both sides of our formula by m plus 5, we're going to start to get rid of the fraction. So we'd end up with y brackets m plus 5 equals m plus 4. Multiply out the brackets now, and we have my plus 5y equals m plus 4. And now we need to get our m terms onto one side of the formula and our other terms onto the other side of the formula. So let's take off 5y from both sides. So my equals m plus 4 minus 5y. Let's take an m off both sides to move the m over to the left. So my minus m equals 4 minus 5y. And now we've got all of our m terms on one side of the formula. We can actually factorise the m's out. So this becomes m brackets y minus 1 equals 4 minus 5y. And finally we can divide by that whole bracket that's on the left hand side. So m equals 4 minus 5y over all of y minus 1. We've got our m as the subject of the formula. Again, there's a few different variations depending on the order that you did things in that you can have that are still going to be correct answers for this one. So if it's marked correct, you're absolutely fine with it. But if not, you made a slight mistake. But this, I thought, is the simplest way of explaining it. As I say, there are a few variations that are possible. Number 31, there was a mistake in the quiz here, so I'll be very lenient with marks on this one for yourselves. It did say for a while multiplying fractions at the top, which obviously none of these explanations actually describe, so it should have said dividing, which I think a few people worked out. So to divide fractions anyway, you find the reciprocal of the second fraction and multiply. There's quite a lot of people remember that as the acronym KFC. So keep, flip and change. Keep the first one, flip the second one, and change the sign to a multiplication. My apologies there. There's a not an obvious mistake on the quiz. Number 32 then is recurring decimals into fractions. So we've got recurring decimal here, 0.363636. We could also have written it with the dots above the 3 and 6 to show that's the start and end of the repeating pattern. And to convert this into a fraction, then we need two expressions that match these recurring decimal places. So because this has two digits that match or recur, then we need to get rid of two decimal places from our number, which would be multiplied by 100. So 100x is going to equal 36.363636. Our original term then can stand for our original decimal, so x is 0.363636. We can see here that our decimal places are going to match, so we can take one term away from the other now. So 100x take away x leaves us with 99x, and 36.363636 minus 0.363636 is just going to leave us with 36. So now we can solve for x. We've got 99x's here, so let's divide both sides by 99. So that gives us x equals 36 over 99. But of course we need to simplify this, so we can divide both of these numbers by 3, of course, to start off with. So that's going to give us 12 over 33. Well, that's still in the 3 times table, so actually we could have divided by 9 straight away. And that's going to give us 4 over 11 as our simplest form of that fraction. So the idea here is you've got to match those decimal places in your two terms that you write in order to cancel them out when you subtract. Number 33, decrease 6 by 5%. Well, 10% of 6 is 0.6, so 5% is 0.3, and if we're subtracting then we want 6 minus 0.3, and that's going to give us a 5.7 as our answer, and we're done. Okay, number 34 then, percentage multipliers. So which of the following is the multiplier for an 18% decrease? So there's not a huge amount of us got this one correct, so I'd like us to make sure that we're thinking of our original amount of 100%. Now in this case we've got an 18% decrease, so we're taking that away from the original amount. So if you remove 18% from 100%, you're left with 82%, and it's that leftover amount that we then turn into the multiplier by finding the decimal equivalent of it, which is our 0.82. So be careful with those. A diagram can be really useful for helping with the multipliers. They're pretty key for some of these later questions that we're going to need to be able to do. Number 35 then, this is going to use our multipliers. So 540 is placed in the bank account giving 3% interest. How much is in the account at the end of 5 years? Well, first off, let's get our multiplier. So our original amount is 100%. We're going to have 3% interest added on. So overall, we're going to have 103% of our original amount. And as a multiplier then, that would be 1.03. That's going to be affected over 5 years for this account. So we need our original amount, 540. We times it by the multiplier, 1.03, and you can do that 5 times if you want, or the easier way is to do it to the power of 5 for the years. So 540 times 1.03 to the power of 5, it gives us 626.008 pounds. Now, because it's in pounds, we need to round appropriately to 2 decimal places. And I did accept sort of either way of rounding here. If you're going to do a strict mathematical rounding, then when you cut it off after the pence, the 8 rounds up and you get 626 and a penny. Or if you were thinking about this in real life, you haven't quite earned that penny yet, so the bank might be really stingy and not to round up and just say that you haven't earned it yet. So I'd also have accepted 626 pounds and 0 pence, or just if you put 626 pounds That'll be fine as your answer there as well. It's all to do with getting the multiplier here and then doing that to the power of those 5 years. Number 36, reverse percentages, another one that a few people are going to need to have a check up on as far as the multipliers go. So a mobile phone's price is reduced 12% in a sale and now costs £323.84. What was the original cost? So we had original and then the sale. So the original was 100%. We've removed our 12% from it. Excuse my email going off in the background there, which then leaves us with our 88%. So the multiplier for that is 0.88. Now what that means is the original was multiplied by 0.88 to get to the sale price, but we're working in reverse, so we need the sale price divided by 0.88 to get back to the original. So the sale price divided by 0.88, so that's 323.84 divided by 0.88, and it gets us back to our original price of here, that is a pound sign, £368. So multipliers are absolutely key for our high-end percentage work, so have a look back over those if you need. So that should be all of our answers there, so you should have got any corrections that you needed. So thank you for engaging with our run of online lessons. I've had some fantastic work from people. It's been really, really impressive to see. There's a few names I'll be looking out for when we come back in September. As I said, there's no need to register via Show My Homework today because there's now a little online form for you to fill in. So there's another Microsoft Forms link at the bottom of your Show My Homework for today, and this is just going to give you a quick form to fill in to RAG rate each of those topics. So we didn't do this at the end of the quiz, just in case that you only needed a quick reminder of what to do. So now that you've had the reminders and the corrections, I'd like you to RAG rate each of those topics. A red will mean that you're not very confident, an amber will mean that you're somewhat confident, and a green will mean that you're very confident in those topics. And what I would suggest is maybe if you do have the time, if you are a red or an amber, then it would be really useful to look over those videos again or lessons just before we return in September so that you've caught up, because each of the topics that we've covered during the lockdown lessons should have been revision topics for you. Although there were some extension activities there that might have gone beyond what you'd seen in lessons previous to today. So thank you very much for your engagement with these lessons. As I say, it's been an absolute pleasure to see some of the work that people have been handed in for them. If you do need any assistance, please get in touch with me at red@theroyal.school. And if not, it might be September before I speak to some of you again. So have yourselves a wonderful summer.